Good afternoon to all of you. Myself Dr. Ravikesh Kumar, Assistant Professor Agronomy in the Department of Faculty of Agricultural Science and Allied Industry, Rama University, Kanpur. Before the moving our topics, I could explain that if agriculture goes wrong, nothing else will have a chance to go right. It quotation be given by Dr. M.S. Swaminathan. He also known as the father of agriculture in India. So, let us on my topics are moisture conservation practices for enhancing the productivity in dryland agriculture. Because the moisture are major constraints in agriculture sector. Without moisture, it is impossible to produce any crops in the fields. This is a highlight of topics. First, introduction, type and characteristics feature of dryland agriculture, and dryland situation in world, South Asia and India. What is the situation of the drylands in overall world, Asia and India? Importance of dryland agriculture in Indian economy, problems of dryland agriculture, and how to the moisture conserved by in situ and ex situ methods. And second, what the government support for development of these areas, and last is the conclusion. First of all, introduction. Dryland agriculture refers to growing of crop entirely under the rainfall condition. Means that the crops which grow are totally dependent on the rainfall is known as the dryland cultivations. Drylands area are characterized by the low and erratic rainfall and no ashore irrigation facility. It is the form of subsistence farming in the regions where deficit of the soil moisture retards the growth of the water consumption crops. Dryland areas receive rainfall are less than 750 mm to more than 1150 mm. India will need 353 million tons of the food grains by 2050 to feed the population, because the populations are increasing by day with very drastic manners, but in this way land are reduced day by day by the moving or making the infrastructures, making the houses, etc. Types and characteristics feature of dryland agriculture. Mainly drylands agriculture are divided into the three different groups. First all dry farming, second dryland farming, and third is the rainfed farming. What is the constituent of the all three categories? In the as per the rainfalls, dry farming receives less than 750 mm rainfalls, where dryland farming receives 750 to 1150 mm, while rainfed farming receives more than 1150 mm. What is the moisture availability? In dry farming, totally shortage of the moisture, or it say that due to the severe shortage of the moisture, in this conservation practices necessary for the economic crop production. Without that, it can impossible to growing of the any crops or any production in dry farming areas. Dryland farming or moisture are the limited conditions of shortage, but in this area also need some the conservation practices like in situ or ex situ to produce the optimum crop production. While the rainfed area receives more rainfall due to the precipitation will be the sufficient assure the crop yields. In crop growing seasons, dry farmings are growing days are the less than 75 days, while dryland farmings are 75 to 120 days, rainfed farming are the less than the 120 days. A major constraint in dry farmings, major constraints of dry farming are soil erosions like wind erosions, where dryland farmings are wind and water erosion both. In rainfed farming are due to the high rainfalls, water erosion are the very big problems. It could need the drainage by making the drainage or any the runoff managements are need to save the waters and produce the crops. As per the crop failure, dryland farming has the most common due to the prolonged dry spell, means that it has no it had to the successive rains has the many more gaps, causes the crop will be the failure by the lower moisture availability. In dryland farming, in spite of the prolonged drought spells, crop failure is relatively less frequent. In rainfed farming, crops are not frequently subjected to soil moisture stress during the crop growing period. Dryland area, the words are due to the denoted by aridity index. Hyper arid area are the like the some denoted by red colors, arid areas are denoted by yellow colors, while semi arid are denoted by light yellow color, where other some humid and non dryland area are denoted by brown color. This is the natural resource and land use in the South Asia. In India, the total geographical area of the 328.73 million hectares area. In all over the areas, 307.75 million hectares area are the reported. In the grass cap total area, grass cap area is denoted 197.7. If we can say about the rainfed area, or 7.2.21 million hectares are area are totally depend on the rainfalls. Mean that you can say we have 51.75% area of the total cultivated area are totally dependent on rainfall, because here where no any irrigation facility are available to produce the optimum crops. Percent rainfed area, non-crop area, different crops in this graphs are also denoted by that. Importance of dryland area. Dryland agriculture is important for economy as most of the coarse grain cereals, pulses, oil seeds and raw cottons are grown in these lands. It also supports 2/3 of the livestock population and are the critical to the food security. We can say 44% of total rice production is contributed by the rainfed areas. Coarse cereals like sorghum, pearl millets, maize या other जो है कि minor millets are the contribute 85% of the total production, while food legumes are contribute 85% of the total production. Oil seed are also contribute 72% of the total production. Cotton are contribute 65% of the total production. Minor millet are contribute 90% of total production of minor millets. Overall, dryland contribute the more than 40% of the production of total agriculture. Major problems and production in the dryland agriculture like late onset and early cessation of rains, low fertility of soils, inadequate and uneven distribution of rainfall, prolonged dry spell during the crop period, insect, pest and weeds, poor crop management, establishment and moisture conservation. We can focus on them because the moisture are the most limiting factors in the dryland agriculture for our economical practices, and input in crop production depend on it. This is the also denoted the situation of the farmers. Moisture conservation practices, the main objective of the soil moisture conservation practices. Moisture conservation practices, the main objective of soil moisture conservation is to minimize amount of water loss from the soil through the evapotranspiration and runoff. Why it is essential? It is essential for the we can know that the dryland agriculture are totally dependent on the rainfall. So, if the off seasons like winters or summer season, moisture or unavailability of moisture, if we conserve the moisture like the in situ or in situ the moisture conserved by any management practices, we provide the moisture in the severe scarcity situation, so it can help or produce the optimum crop. There are two types of moisture conservation techniques are used. First, in situ moisture conservation techniques, and second, ex situ moisture conservation techniques. In situ moisture conservation techniques are like some locations adapted by the some locations are India in arid regions where the rainfalls are received the less than 500 mm. Contour farming, cultivation, conservation, furrow mulching, deep ploughing and inter-row water conservation system are used to conserve the soil moisture. Like semi-arid regions, conservation furrows, contour farming, compartmental bunding, runoff, strip, tide range, etc. are the major conservation practices adopted by the semi-arid regions. and subhumid regions are the some agriculture practices like field bunds, graded bunds, vegetative bunds, etc. are the adapted to conserve the soil moisture and produce the optimum crops. In the first, water conservation practices like land configuration. The land configuration or conversion of the land by any like furrow, deep furrow, broad bed furrow, etc. to conserve the moisture in situ or in the fields to retain the soil moisture at long times or they to contribute to the water tables, we can the available to the large time for the agricultural crops. Land configuration, first are the broad bed furrow, second and the broad bed and broad furrows, third ridge and furrows, dead furrow, fifth micro catchment, sixth compartment bundings, etc. are the methods are used by the scientists or other management practices like farmers, contour bunds, contour tillage, bent traces, etc. are the conservation practices, in situ moisture conservation practices adopted by the farmers to conserve the soil moisture at long time to retain in situ in the fields and it available to the severe moisture shortage condition. Many scientists are also the reported by different scientists effect of the broad beds, furrow and soil amendments on physical properties of the soil yield of the soybean. The scientists are reported broadbed furrow plus application of FIM at the rate of 2.5 ton per hectares plus gypsum at the rate of 1.25 ton per hectares found higher grain yield as compared to the others. Second scientist Babu et al. 2020 impact of the land configuration and organic nutrient management on productivity and soil properties under the baby corns in eastern Himalaya regions. He adapted the broadbed furrows by land configuration method and found more soil organic carbon 1.47 hectares, bulk density of the soil 1.34 and gave the higher yield 22.18 tons per hectares and also found the higher baby corn yield by the conserving the soil moisture. And others also they adapted the organic nutrient management practices in composition with the land configuration. He can found the FIM 6 ton per hectares plus vermicompost 2 ton per hectares found the better yields as compared to the other treatments and control practices. Third scientist Thakur and co-worker 2011 also works on the effect of the land configuration and mulching on soil moisture content at harvest and yield and economics of sorghum. He also found ridge and furrow systems of in situ management practices was found higher soil moisture content like 0 to 15 centimeter if count 19.84, 23.38, 15 to 30 centimeters of the soil depth and 24.76 at the 30 to 45 centimeter and also the found high sorghum yield 5.58 tons per hectare due to the in situ conservation of the soil moisture practices. Birhanu and co-worker 2020 also reported that grain yields of the crops in field with and without contour bundings in Mali, Nairobi, Kenya, research of the Nairobi, Kenya. He can found the higher yield obtained by the crops maize like with the adapted by the contour bundings. Second method of the water conservation in situ water conservation like tillage. Tillage has also makes influence on the soil hydraulic characteristics because the tillage also the breaks the hard pans to improve the water's absorption or percolation of the soil systems. Like first use the summer ploughing, we are also the adapted in the summer seasons deep tillage means by the mouth wall ploughs or any the disc plough to adapt to turn the soils and means it retain the soil moisture at the time of the rainfall and it could provide the situation to percolation at the long times. Like chisel plow are also used for the breaking the hard pan to increase the percolation of the water. Conservation tillage also reduce the soil erosions and also improve the soil moisture availability at the long time due to the covering of the mulchage and other like the situations. Effect of the Singh and co-worker 2030 also work on the effect of the different tillage practices, yield and economics of the cottons. He could found the deep plow with the disc plow found higher seed yield 0.69 kg per hectares and net income 19,229 rupees per hectares and moisture content and 0 to 30 centimeter depth 1.9 percent moisture and available to the soils. Khan and co-worker in 2021 also reported that effect of the conservation tillage practices on green fodder's yield of different fodder crops and soil moisture depletion. He also found the zero tillage was the better soil moisture conservation and found the better yields as compared to the other management practices. Second, cropping system in dryland agriculture. Cropping system are also used to conserve the soil moisture or the moisture produce the high water use efficiency. Like intercropping, growing of the maize plus black gram in 1.2 ratio after the every 1 row of the maize 2 row of the black grams in soil. Advantage, higher income per unit area by increasing the yield, maintain the soil fertility, better utilization of natural resources, increase the water use efficiency, reduction in soil runoff and control the weeds. And other mixed cropping practices are also to increase the water use efficiency by the different cropping practices. Like cropping systems are the intercropping system. Chaudhary and co-workers are reported that 2012 soil moisture is influenced by the maize and legume intercropping. Maize cowpea ratio of 1:5 ratio also produce the maize crop ratio 1:2 ratio are the also found higher soil moisture content and give the equivalent higher yield as compared to the other management practices. Crop and varietal selection in dryland agriculture. How could crop and varietal affect the selection of in dryland agriculture? The criteria of choice for crop variety for dryland is some like it could be able to tolerate to the drought. It has a fast growing during the initial period to withstand harsh environment. It has also ability to genetic potential for high yield. It could also ability to short or medium duration, adaptive to the wide climatic variation or and responsive to the fertilizers. Some improved variety are suited for the different crops and variety are available for the rain-fed agroecosystems. Next, nutrient management in dryland agriculture. Many scientists is said dryland is not only thirsty but also hungry. Means that dryland is not only the required the soil moisture, it also has the required to the nutrient because the moisture and nutrients both are the compatible to the each other. If the moisture availability are the lower, so exoosmosis takes place, means that the water of the crops are move out in soils due to the higher metric potential of the soils or solute potential of the soil, causes the crop are showing the building to the unavailability of the rainfalls or the soil moisture. Use of integrated nutrient management, like some management practices, use of integrated nutrient management, application of fertilizer totally depend on the moisture status of the fields or many etc. How to the control it? Nutrient solution spray is recommended in the event of the reveals of the rains and release of the soil moisture stress. Spray of the many fertilizer like 2020 SSP, urea spray, potassium like fertilizer, etc. are the spray to the counter the such effects in dryland agriculture. Some scientists, Srinivasan and co-worker 2019 also found that the impact of the foliar spray on the yields of the different crop during the dry spells. He could found in Agra regions, pearl millets application with the urea 2% plus potassium nitrate at 2% was found more higher yield at more than 71% of the higher yield as compared to the others. How could mulching affect the dryland agriculture? It helped to prevent the weed growth, reduce the evaporation and increase the infiltration of the rainwater during growing season. Type of mulcher, different types are the mulches available like that: surface mulching, vertical mulching, live vegetative barriers. How mulchings like works? If mulching the cover the soil surface, reduce the direct impact of the sunlight on the soil surface, causes the it improve the soil moisture, it's improve the evaporation losses and it's reduce the evaporation losses or also improve the microorganism, soil organic matter content or water holding capacity of the soil, causes the increase the yield in the mulchage condition of the soil. Different types of the mulchings are available here like grass clipping, straw, dry leaves, soil dust. Different mulch are like gravels, pebbles, vertical mulch, live vegetative barriers. It is the use for the mulchings of the mulchings of the fields could reduce the water erosions. Reduce the soil erosions or also improve the water holding capacity and also reduce the evaporation losses of the water. Like bead are also the many impact of the soil management practices. How can the display like the image? How the irrigation water applied to the crops and what amount of the weeds consumes water and what the drops are used for the crops. Some response of the different mulching moisture conservation practices. Extra mulching and opening furrow soil also found the best superior about the other control management practices. Many scientists have also reported like that effect of the live mulchings and legumes or sunhams mulching at the 30 days and Daicha mulching at the 30 days also found the superior about the all over the practices like crop production. Alternate land use patterns are also like agroforestry, fodder cultivation, pasture development, afforestation, also the impact on the agriculture and reduce the and increase the water evaporations causes the many water losses. To impact on soil surface like the improve the erosions, etc. Soil amendments in dryland agriculture, many soil amendments like core pith, compost, hydrogels, jaxal shakti, etc. are used to improve the attract the waters in the soil sample and compost soil surface to reduce the evaporation losses and increase the water use efficiency of the crops. Many scientists are also reported like that and like Thar and co-worker 2000 that's also found the foliage mulch 5 ton per hectare plus Jal Shakti at the rate of 5 kg per hectare was found superior about the all the management practices. Anti-transpirants are also available to use the dryland agriculture for reduce the evaporation losses like metabolic and stomatal closure types, atrazine, PMA, fill farming type, reflective type, different anti-transpirants are used. And also many scientists are reported like that psychocell or it is anti-transpirants are the found superior about the other over control management practices. Access to water conservation practices, conservation and collection of excess rainwater in storage structure, harvested water like many different structure like the rainwater harvesting, pond, tanks, etc. to use and save this water and use to the futures for the crop productions. Like in farmland water used for the like farm ponds, percolation pond, different types of the percolation pond maintained to control the water and also use the check dams, jalkunds. Micro irrigation are also the same like water, it could reduce the water at 40% and also use the increase the water use efficiency at 95%, like different management practices like drip irrigation, sprinkler irrigation. Many scientists also reported that irrigation with the ball development stage, irrigation with the flowering stage was the found many superior about the all over management practices. Many governments also effort to the development of the rainfed dryland area like due to many programs like Nawada National Watershed Development Programs for rainfed areas to continue about the 1990 to 91 National Rainfed Area Authority, Rainfed Area Development Programs, Jal Jeevan Haryali, etc. are the programs are launched by the governments of India and as well the state governments. Conclusion, The importance of the rainfed agriculture is varies regionally, but rainfed areas produce most food for the community, or it can be explained that it has produced more than 50% of the production in rainfed area. It is the very important for the agriculture point of view as well as the food security, or we can say that it need to the agriculture productions. Thank you.